Ever wondered what makes your phone vibrate or your earbuds sound so powerful? The answer is a tiny, super strong neodymium magnet. These aren't your average fridge magnets. They're the strongest permanent magnets you can buy. Neodymium magnets are everywhere, quietly powering our gadgets, cars, and even green energy systems. Their secret? An incredible strength to size ratio, thanks to their rare earth composition. From spinning hard drives to massive wind turbines, these magnets are the hidden force behind modern technology. Today, we'll dive into what makes them special, how they're made, and why they matter. Let's begin our magnetic journey. What sets neodymium magnets apart? Their strength is unmatched, over 10 times stronger than typical ceramic magnets. This power comes from their unique atomic structure, a blend of neodymium, iron, and boron, forming a crystal lattice that aligns magnetic domains perfectly. The result? A compact magnet that packs a punch, letting engineers design smaller, lighter, and more efficient devices. They're also highly resistant to losing their magnetism, making them reliable for years. That's why your tiny headphones sound so good, and why electric motors can be so compact. Neodymium magnets have revolutionized product design across countless industries. Their combination of strength, size, and stability is the magic behind so much of our tech. It's no exaggeration, they've changed the way we build the modern world. Like any superhero, neodymium magnets have strengths and weaknesses. Their superpower is brute magnetic force, making them essential in motors and electronics. But they're brittle, more like ceramic than metal, and can shatter if snapped together. Heat is another enemy. Above 80 Gleisdi, they can lose their magnetism for good. Engineers sometimes add costly elements like dysprosium to help, but it drives up the price. Corrosion is a threat too. Unprotected, they rust from the inside out. That's why you'll always find them coated in nickel, copper, or even plastic. These coatings shield them from moisture and damage, ensuring a long life. Their power is impressive, but it comes with challenges that must be managed. Making a neodymium magnet is like crafting a high-tech cake. It starts with mining and purifying neodymium, iron, and boron, rare earth elements that require energy-intensive processing. These are melted together, cooled, and ground into a fine, reactive powder. The powder is pressed into shape inside a strong magnetic field, aligning the particles for maximum strength. This fragile block is then sintered, heated just below melting to fuse it solid. After cooling, it's ground to its final shape with diamond tools. Next, it's coated for protection, usually with nickel or plastic. The last step, magnetization, where a powerful electromagnet locks in its super strong field. Each step is precise, ensuring the magnet's strength and durability. The result? A tiny powerhouse ready to drive the world's technology. It's a blend of chemistry, physics, and engineering at its finest. That's how a handful of powder becomes a modern marvel. Neodymium magnets are everywhere, often hidden in plain sight. Your smartphones, speakers, vibration motor, and camera all rely on them. Headphones and earbuds use them for powerful, clear sound in a tiny package. Hard drives, power tools, and even electric toothbrushes depend on their strength. In cars, they're found in motors, for windows, seats, and especially in electric vehicles. Wind turbines use massive rings of neodymium magnets to generate clean energy. Even MRI machines in hospitals depend on their powerful magnetic fields. These magnets are the silent workhorses of modern life. Once you start looking, you'll spot their influence everywhere. The advantages of neodymium magnets are clear, unmatched power in a tiny size, enabling smaller, lighter, and more efficient tech. Their high resistance to demagnetization means they last for years, even in demanding environments like wind turbines and factory robots. But they're not perfect. Their brittleness means they can break easily, if mishandled. Protective coatings help, but if damaged, the magnet can corrode and lose strength. Cost is another factor. Rare earth elements are expensive and prices can fluctuate. High temperatures can sap their power unless special, pricier versions are used. These trade-offs mean engineers must carefully weigh when and how to use them. Neodymium magnets are amazing, but not always the right fit for every job. Their strengths and weaknesses shape the technology we rely on. It's a balancing act between power, durability, and cost. With great power comes great responsibility. Neodymium magnets can be dangerous if mishandled. Large magnets can snap together with enough force to injure fingers or shatter, sending sharp fragments flying. Swallowing small magnets is life-threatening, especially for children. Their strong fields can interfere with pacemakers and other medical implants. Environmentally, mining and refining rare earth elements can cause pollution if not managed responsibly. Recycling these magnets is tough. They're small, coated, and embedded in complex devices. As demand grows, finding greener ways to produce and recycle them is crucial. The challenge, harnessing their power without harming people or the planet. The story of neodymium magnets is still being written. Scientists are working to reduce reliance on rare, costly elements and to make magnets more heat-resistant and sustainable. New manufacturing methods like 3D printing could cut waste and enable custom designs. Recycling is a top priority. Finding ways to recover rare earth materials from old devices is key. These innovations promise stronger, greener, and more affordable magnets. The goal: push technology further while protecting our resources. The future of magnets is all about smarter, cleaner solutions. Neodymium magnets are the invisible force powering our modern world, from your phone to wind turbines. Their unique blend of strength and size has transformed technology, but not without challenges. As we innovate, we must balance their benefits with safety and environmental responsibility. The next generation of magnets will be stronger, greener, and more sustainable. Science is pushing the boundaries, ensuring these tiny giants keep driving progress. The future is magnetic, and it's brighter than ever. Next time you use your favorite gadget, remember the hidden hero inside, the neodymium magnet.